Working principle of three-phase induction motor. Now it's summer, you must have noticed your fan. So let's get inside the fan. What it has an induction motor. So this is the stator which remains fixed, and the rotor to which the fan blades are connected is the one which rotates. So stator remains fixed and the rotor rotates. This is the basic concept and the two main structure of induction motor. So first what happens, we give three-phase balanced supply to the induction motor. Okay, electric circuit switched on, three-phase balanced supply is going inside this induction motor. Now what happens then? Three-phase induction motor, it goes, then three-phase current circulate in the stator windings. This is a stator, there are different windings inside this. Now supply is given, current flows through this stator windings. Now as the current flows through these stator windings, three-phase fluxes are produced. Now as the flux are produced, we know a rotating magnetic field is produced. So supply is given, current flows, and the rotating magnetic field is produced. And this is our rotor, conductor half part is inside this. So the rotating magnetic field now cuts the conductor. Now as the rotating magnetic field cuts the rotor conductor, and EMF is induced, or the voltage is induced. This is said by Faraday's. Now by Faraday's law, we know that the voltage is induced in the rotor conductor. So because of the change in magnetic field and the cut in the rotor conductors, some voltage is induced in this rotor conductor. Now this is the main thing we need to understand, why it is known as induction motor. Here we have not given a direct voltage to the rotor. It is by the induction, it is moving. That is, voltage is induced after the magnetic field cuts the rotor conductors. This is why it is known as induction motor. Now as we know, the cause of this is the rotating magnetic field. So by Lenz's law, we know the current flowing in the conductor produces a force. Now a current is flowing through this rotor conductor. Now it will feel some force. Because of the force, it will tend to move. Now the shaft is moving. Now it is moving. Now we know by Lenz's law, it opposes the cause of it. The cause of it is the rotating magnetic field. So it moves in the same direction of the rotating magnetic field, as it is written here. So that is opposes the cause of it. Now the rotor rotates here. The rotor rotates in the same direction as the stator field, rotating magnetic field. But this rotor speed is always less than the synchronous speed. Now what is synchronous speed? The synchronous speed is the speed in the produced of that rotating magnetic field inside this stator. Now this rotor, the speed of rotor is known as rotor speed. Ns, synchronous speed of magnetic field, and the Nr, the rotor speed. Now this rotation of rotor is always less than that of the rotating magnetic field inside this stator. The difference between this speed is known as slip. Now the question may arise, what if the rotor and the stator magnetic field rotates with the same speed? Now in that case, there will be no rotating magnetic field. And if there is no rotating magnetic field, no EMF will be induced, so no current will be produced, so no force will be produced. Okay, so at the end we won't get anything. So it is always necessary that Nr is always less than Ns. This is the whole working principle of three-phase induction motor.